So welcome everybody to our special webinar on testing iOS applications with QF-Test. I'm happy to be here together with my colleague Max, who will join me, who will answer all your questions which you might post in the chat, and as well can answer more questions if I'm out of ideas. So together we will have a good time, approximately 1 hour about iOS testing. And you might have wondered, why did it take so long until iOS testing was implemented for QF-Test? I'm doing now Android testing for years, and I had to wait until this autumn to connect my iOS devices with QF-Test. And maybe our first short overview over the architecture will shed a little bit of light on this. So as you know, QF-Test consists of several parts. We have one application. This is the QF-Test main application, where you design your tests. You describe how your application is started, which you are testing, which checks you have to execute, and so on. This is like the QF-Test main application, and this then connects to the system under test. And if you, for example, test a Java application, let it be a Swing application or SWT, then directly QF-Test communicates with that application. But when you're executing a web test or an Android test, then QF-Test needs some controller helper application, so some counterpart to communicate with, which represents then the tested application and as is communicates with the, let's say, browser or Android device. And for iOS, that is exactly the same. We have here the iOS controller. The iOS controller is an application which you can find then in the dock of your system, which looks with an icon looking like the QF-Test icon, but with this iOS bubble. And this is the helper application which acts as the client for QF-Test and which controls all the interaction with the iOS device. For this, we use a couple of standard development tools from Apple and open source tools. For example, the Python-based iOS development bridge tool, which help us to communicate with the device, install application, query which devices, simulated or real devices are available, etc. And for this, the iOS development bridge also contacts the Apple development tool, which is called Xcode. We also want to communicate directly with the device to execute our tests, to query the current application state, and so on. And for this, we need an application-specific agent. Xcode is also compiling this agent at runtime, so it says it's instrumenting the device. So we need the agent code. This is bundled with QF-Test. You don't have to care about that. But on your system, where you execute your device, your iOS tests, you need Xcode installed and the iOS development bridge. That means Xcode only runs on macOS systems. Therefore, you also need a macOS system to run iOS tests with QF-Test. This is all explained in detail in the manual. Luckily, you don't have to read the complete manual, but QF-Test has a shortcut function to set up or to check whether your system is properly set up or to help you with that. So let's head over to QF-Test. I just focus on that. In the clients, the extras menu, you will find this third entry here. It's check or set up the iOS test environment. And when you run this, there's some introduction saying that in the next step there will be a procedure called, and this procedure will check whether your system is ready to test. You can also directly jump here to the manual where everything is explained in detail, but we are feeling lucky. We just run the check. It checks here if all required runtimes are installed, and now it finds that something is missing. Okay, I'm cheating here a little bit. I just renamed the required file to show you the dialog. But if something is missing, it looks like that. And then you can decide whether you just ignore this, which is normally not a good idea. except if there is you have the latest Xcode installed. There is a change in the output format, so QF-test currently with 8.01 doesn't recognize properly that the iOS runtime is properly installed, and it says I cannot interpret the result. Do you want to continue? There you can safely say continue. We don't want to skip here, but we want to install this missing part, which is the IDB companion. It's part of the IDB, which communicates with the device. Here it says a terminal application has opened and is executing the required commands. We have to thoroughly check what it's saying here. In fact, it says, oh, you fooled me. It should be installed already. Well, which is okay because I really fooled Homebrew here. So I use this reinstall IDB companion command here to fix it. And now, hopefully, everything is fine. And we can start executing our iOS test. So let's run this again. Run the check again. It runs the same checks as before, but now the IDB companion is found and all the other requirements are found, and it says the environment seems to be ready for iOS tests. If you're really into this and want to know what went wrong in the last step, why was there this error, you can check the run log here, and you see check iOS testing environment in fact is a test was executed by QF-test. You can navigate into the run log, you can jump to the error, for example, where it said IDB companion is not installed, and now you can get into the details. For example, you can check here, oh, well, it tried to find the IDB companion, it tried to get the part of the IDB companion, and then it says there was no path, so it couldn't find the IDB companion, which in fact is the same as the message says. But well, with that you can debug your system if you assume everything would be all right, but QF-test still claims otherwise. So running the test is just running the setup sequence is just like running a test from the menu. Now that everything is fine, we can start watching our how the iOS test looks like. We have a sample here in our sample test suites. You see we have here the iOS car config suite. You'll know this car config application from all the other UI engines we support. In QF-test 8, there's a second way to open the sample suites, which is in the bookmarks menu. You have here the same list, so I can select iOS car config suite here and open it. And you see the suite is pretty much the same way constructed as it is for all the other test suites, sample suites which we ship. There is a dependency which starts the system under test, and then there are several small test cases which are executed on this system under test on the application. So I just run dependency to get up my system under test, and you will see in the terminal here some outputs. It's connecting to the first device it finds. In this case, it's the iPhone 15 simulator. It's building the instrumentation. This is the part where Xcode comes in, and then starting the agent. You can see the little agent icon here on my simulated device. It installs the car configurator, starts it up, and now it says everything's fine. It could connect to the simulator, it could connect to the agent on the simulator, and now we are all set to run the test. So let's run one of the tests. Let's see. Let's run this test, which selects one vehicle here in the list and then checks whether the price is correctly written. It's correctly noted down there. So let's run it. Clicks the first one, clicks the second one, clicks the third one. It is finished. Let's have a look why. Well, on the data driver, there is some iteration range here specified. It's just checking the first 3 of them. So this is like all other QF-test tests. You can use data drivers to get your data into it. You can use event steps to issue events on the device. or in the application on the real or simulated device, you can use check steps to check the current state, etc. So we can simply here, for example, say, okay, the first one is interesting, and then the say middle one and the last one are interesting. Let's check those, and then we run the test again. In the dependency, QF test makes sure that everything is set up fine, and then it checks the first, the middle, and the last one of this list, and everything's fine. Well, everything was fine until there was some inflation. So let's say this last module, which was pretty cheap, now is a little bit more expensive. And let's run the test again. So, oh, well, there's an error, of course, because the application hasn't been updated. Let's see what the error is. And if you jump to the error, you see you get the same comparison mismatch, which we expect here. And you also get a screenshot of the device in the full resolution of the device. So it looks a little bit big here. Let's just scale this a little bit down. So you can see how the device, how the application looked, or the screen of the application looked at the moment where the error occurred. So, well, you say, well, it's a little bit boring. That's all like I've done with web tests or with Android tests. In fact, yes, exactly that was our idea. Make iOS testing as simple as it is doing the other tests with QF test. And you have the same broad possibilities which you have with QF test, all the check steps, all the event steps, all like procedures and so on. So the structure is the same. And of course, you have also the possibility to record your steps. So you don't have to write script by hand. You can click on the record button, and then you see that the simulator has closed, and instead there was here this recording window opened. This is a little bit a difference to your, let's say, Java application or web tests, because for Android and iOS, it's not possible to directly get the events from the hardware device or from the simulator, but we need a simulation layer in between. And we get this by this recording window where you have the screen mirrored all the time. So it's a live mirroring of the screen from the simulator or the device, and you can interact and record your test here as you would do, for example, on the web page directly. So you've also seen that the simulator is automatically hidden, so you don't click falsely in the wrong window, and as soon as the recording window will be closed, the simulator will be reopened again or shown. It's just hidden in the background. You can now record clicks simply by clicking on the respective element. You can say, okay, I want to record a click. You see with the highlight, QF test has found all the components. And I say, okay, I'm interested in that one. So I click here. It gets the current state of the element, and I open a new test suite here. And let's stop the test. And now here I have exactly what I expect. I have a mouse click on the first vehicle, and then I can say, okay, let's check the text over here. Can let it run. Well, no difference here because it was like it was before, so let's select something else. Let's run it again. And as expected, it clicks on the first item here, which is already a list item. So I can also say, okay, click here, the first item, and let's run it again. It selects this first list item, checks the price, and everything is fine. So simple text checks we've seen. You can also think about other checks. Let's say I want to check this little icon here. So I click with my secondary, the right mouse button, and I have the pop-up window where I now can say, okay, let's do an image check, for example. Then it fetches from the device, the original image in the high resolution, and you can here see that it compares the image to the image over there. You can run it, you can check it, and you can also here, for example, select some region. I'm just interested in that region, for example. You can define algorithm to improve the comparison in situations where the icon might look a little bit different, etc. You can also change your nodes here. So let's say I don't want to have a check here, but on the same element, I want to execute a tab, which is in this case a mouse click event. So we translate mouse click events into tabs. Let's execute. And then the settings panel comes up. So let's record to close the settings panel again. Unfortunately, there is no button here to close, but we know we can swipe this just down. So swipe gestures are also easily to record. Just start, drop down, and to leave the mouse button, and then it records the swipe. Here you see it's the same swipe selection event as you know maybe from Android. You have here automatically recorded some coordinates and some more numbers. If these numbers are strange for you, just use the what's this functionality. And in the manual of QF test, all these details are explained. So in the Android and iOS section here, it says a swipe starts with a start coordinate, ends with the end coordinate, and then you can specify the time in milliseconds and the steps, how many steps will be replayed. For example, because I was doing the swipe a little bit slow in the recording window, it was also replayed slowly here. So I can just say, okay, let's not use 1.5 seconds, but half a second. And let's execute that again to show the settings window. I hide the menu in the background. And let's execute the swipe. And you see the swipe is now executed pretty faster. In the manual as well, you could see that you can select to swipe into a direction. So for example, up and down seems to be exactly what we need here. So let's show the settings. And then let's swipe down. So we change this here to down. And replay it. It finds the component. So the window to replay it. Oops, that didn't work as expected. Oh, well, because if I would have read in the manual exactly, it says from the top to the bottom of the component. And since I replay here on the top component, which is the car config window, if I double click, you can see here that it is the main window. It replays from the very top to the very bottom, and this is a lock gesture on this device. So let's undo that. Just swipe up again. And now let's go back to the coordinates and just say, okay, I don't need the exact coordinates. I can say, okay, let's go to the target component coordinate, the center and in the south of the screen. And this looks now like a stable swipe. It's pretty fast executing, and it's doing what we're expecting to do. So this is the recording window. The recording window also has this little icon for the inspector. You might also know this already from other test environments like web test. And the inspector here opens a tree view on the page or on the application here. And you can select the inspection mode and select the element you're interested in. And then this is selected here on the right side in the tree. You see how the hierarchy of components is represented and all the detailed information about the selected component. Here you see that it's, of course, an iOS element. It's some type of static text. This is the accessibility type of the element. On the left side, we see the QF test view. So this is a component for QF test, and in detail, it is a label. You can use this when you're registering resolvers for your components. And UI responder here is the type of the element which is originally in the application used. Maybe there's a little bit confusing. Let's select, for example, this text field here. And you have seen the highlight on the left side, and the text field is a UI text field, which is the generic text field. You can also see on the bottom here that different attributes are automatically collected, and then when you record the component, start in the extra features table. And here as well, you find the base type, which is the base type in the application. You find the class which is used by the accessibility layer. You find the labels to which it is mapped by the QF test label algorithm. And as well, you find here the identifier, base price here, base price without a space in between, which is the accessibility identifier. The developers of the application can either using the accessibility identifier method or with a property in the interface designer directly assign to this component. And as you know from other techniques, names are always a good idea for tests because they help the tests to be stable. We don't have to rely on different attributes like the size or the structure, but we can rely on the explicitly defined name here, a little bit like the ID of a component in the web test. If you want to go quickly to the inspector, you can also use the menu of the iOS controller application. Here you find the inspector in the tools, as well as in the icon in the dock. You also here have the UI inspector in the menu, so you can quickly enter the inspector mode here. So we've seen the car configurator, which is the default sample application for iOS testing in QF test. But we also want to see how to develop a new test with QF test. So let's get started. Just close this and start a new test. To start a new test, it's always a good idea to use the Quick Start Wizard, either from here, Extras Quick Start Wizard, or with a little magic wand symbol here in the toolbar. You can select, and you want to test an iOS application. Then we select the device on which the application should be installed and tested. Here you have a list of all available simulators and real devices which are detected by QF test. Let's use the same one. This was the iPhone 15 here. Then it asks for the application to install. Here I have prepared an application which I got from an external developer, asked me to test it. And he provided me a zip file where the application, the bundle which was built for the simulator is included. When building an application with Xcode, you can decide whether it should be built for a simulator or for a real device. And then based on this, different code is produced. So when you want to test something for a simulator, you need the build for simulator. When you want to test something on a real device, you need the build for the real device. And if you select the wrong one, during the install step, QF test will test this and then inform you with an error message when you mix them up. So let's start this. And it tries to launch, and then there is an error message and say, well, I could not use this device before because it's already in use here. You cannot run the same test, or you cannot use the same simulated device for two parallel tests. If you want to test something like a chat client, for example, you need to use two different simulators. Let's say we just stop this test here. So we don't have any client, any controller app connected anymore. And then we can run this directly again, detects the target, it updates the instrumentation, and it starts the test, and it installs the application then. And the application is started. So let's go into the details of this sequence which was created by the quick start wizard. So first it says here tests whether the system already is running, because then the device or the simulator has not to be started again. Otherwise, it runs here a sequence which says check iOS testing environment. And here it calls exactly the same procedure as it could call in the setup. With a small difference, there is in the procedure a parameter which is called interactive. And when called from the menu, this is set to true, so you get all the dialogues helping you, you get the installation information. During the default test here, this is not set to true, so errors will be recorded but not reported. Instead, this variable will be set to false, and then the next step, we can stop our test because the system seems not to be prepared to run this test. This is always good to have it in the beginning to be sure that technically the system can run. If you're sure that your system is fine, you can also remove the step, but it's not taking that much time, and you have a second step of security in your test here. And then there is this new connect to iOS device step. It's the only step which was introduced for iOS testing. All the other steps are the same steps as you're using already in your other tests, in your Android test, etc. And here you have the same selection as we have seen with the Quick Start wizard, where you can select from the currently available devices. You can also select more generically, I want any iPhone, or I want any simulated or real device. And then QF just tries to find the one connected device or the best matching simulator to run the test on it. Afterwards, when this is executed, then QF test here you see starts building the instrumentation. It does something. You see little dots. Every dot, by the way, is written for every line of the Xcode compilation process. If you want to see the details here, head over to the settings of QF test. And in the iOS section, there is the option to show all these lines during the instrumentation or also during the test execution. There will be a lot of output in the terminal then, which sometimes helps you to find errors if the test is not running as you expected. But normally you leave it like this, and in case of an error, the error message will contain the output anyway. And then this is all running in the background. And this wait for mobile device step is exactly waiting for the situation where that says open session, and now the test can be executed. If you run this the first time, building the instrumentation and starting the test might take some time. Therefore, there's this long timeout on the step, which you can then change. And the step will be finished as soon as the device is ready, or as soon as the timeout is finished. And when this timeout is finished before the device is ready, you get some error message or some statement that says still compiling or still preparing the test, still selecting the device, whatever the current situation is. Afterwards, we check whether the last launched component or the last launched application for this client process is the one we're interested in. This is important if you run the preparation several times during the test in a dependency, because then the application is not restarted and reinstalled all the time. And in this step, which is now also used for Android, you can specify exactly which application to install or to launch, or both. Xcode always creates an app bundle, which is kind of a directory. You can specify this directly here, but it's difficult to exchange in between computers, or also to check in, to put into some kind of artifactory. So QF test also supports putting this bundle into, or this directory into a zip file, and then automatically extracting the zip file during the execution of this step. And then it waits until the application is launched, and we have the situation here. So let's record some tests. Here we are in the test step, or in the test case. We start recording. Let's record to add some article. This is an application where you can add articles and then read them later. I provide a very interesting web page, which is important, which is qftest.com, a page I visit very often. Let's open that and stop our recording here. So it says add the article and then input the text into the text field and click on to go. So exactly what we expect. All the steps, our interactions are recorded and executed here. If I now close the recording window, the simulator reappears. So I can put this a little bit to the right so you can see this. As soon as we open it, it's hidden. When I close it, it reappears. By the way, you can change this as well in the settings if you like that, or if you like to have the simulator next to the recording window. And also without the recording window, we can execute our test. Now it fails, of course, because the add article button is not available here. So let's say stop, go back to this page. Let's execute it here. It clicks the button, it fills in some text, and it's extracting the text, and you can read it. And by the way, this is an application where you can read your articles like in a book. So to go to the next slide, we just slide to the side, to the left or to the right, and we want to do this automatically here as well. But instead of recording the swipe, I now use a prepared procedure. So I say I want to insert procedure. I want to call this procedure. And I know this procedure is something with swipe, and it's in our standard library. So I type swipe, and I get some procedures here for Android and for iOS, and there's already this swipe left procedure, which I like to have. Here I have to specify my ID to swipe. So let's say I use here my main window. I don't know the ID here at the moment, but I can copy it, for example, from here. So let's say I want to use this one. I could also use the generic launched iOS app component from here. And now I can execute the swipe, and it swipes to the left, as expected. Maybe there's another side. Let's swipe again. And here you see the nice use of qftest in the reading application. There are more interesting procedures. So when I take a look at the standard procedure package here, the iOS package has a lot of procedures, for example, to exchange the content of the clipboard on the device. If you want to copy text from your test into the clipboard to insert it, or the other way around to check it. There are, as I explained already, the swipe procedures to swipe in exactly the correct direction and so on. There are procedures, for example, to clear text fields, and there is a device package here where you can say, okay, let's list all available devices, or to set the rotation of the device. And the set rotation means one value, which it's the rotation. So for example, let's rotate by 90 degrees. And let's execute. And now it rotates, and the article is now readable in landscape mode. And to go back to portrait mode, just set rotation to 0 again. The details are explained in the description of the procedure, and I have it now in portrait mode again. So having those procedures enables you to quickly execute complex operations in your test with the simulated or real iOS device. Sometimes you also want to say to execute some parts of the test only depending on some special or on some device features. Let's say, let's do this rotation, but only when we have a recent iOS 18 device. So let's say, let's put this into an if clause. Let's say only with iOS 18, but here you have to now say what is the type of condition, how can I check the version of it? And there is a quick answer to this. There are special variables defined in the QF test group. So I can say, okay, I want to have from the QF test group a special variable. It's a client variable, so I start with client. And now I want to have the version of it. So it's version here. You can find a documentation of all the special variables in chapter 6.6 of the manual. And then it also needs the information of the name of the client. The name is Flyleaf here. I could also write directly a variable, my client variable here. Oh, that was a wrong letter typed. And now I can say, okay, this must be bigger than 18 or equal. So let's execute it. And it says it executes, but it does not rotate. Take a look into the run log. And as you see, it's expanded to 17.5, which is the version of the simulator here, and it's not bigger than 18 or 18. So the if is failing and rotation is not executed. If we take a look back into our car config demo suite, you see here already is also a check which is based on a variable in our QF test group. In this case, we are comparing if the device kind is an iPhone or an iPad, because in a simulated or real iPad, the vehicle table in the car configurator would be a table, whereas for the iPhone, it's a list. And we have to differentiate here in between those two types. That it is available as a list or as a table, especially as a list, is some kind of special for this car config application. So we embedded a resolver here. You can see when we start our client and the start client procedure, when we start the application, then it's in the SET started dependency. Here it says start application. We have this resolver definition here. And for the iPad table, we need a special resolver for this application. And you can see the resolver is exactly defined as with other UIs. You could execute it the same way. You do an add resolver, and then, for example, here it defines the generic class name for the vehicle table as being a table. So you can use all your knowledge from the other tests you're already developing for your tests with iOS. Another check which we find in the demo here is the check if the iOS version is recent enough. Here it uses main version, so it doesn't care about .5, .6, .7, but in fact it's more or less the same test as we have executed before. And here it checks that the minimal system or the minimal version is met, which in this case is iOS 17, because our car config demo requires an iOS 17 system. If you have to test older systems, either you are on an older macOS, which is not executing simulators with iOS 17 yet, or you have an older device, and you want to just do with the simulator short demo, we have a second demo bundled with QF-test. You can find it in the extra menu. Here is a reference to the test suite, and it's more or less a simple hello world demo. I can show you. Just stop the current application here, and let's run this demo. And it's a little demo where you can say, okay, I enter my name. It says, hello, greetings. So this is for older demos, for older devices, we have this alternative application to test. As we have still some time, I also want to demonstrate how to test on a real device. I already have a real device here connected to my system. As you can't see probably the screen from this distance, I started a screen mirroring application here. So let's close the simulator so we don't get confused. This exactly mirrors what I have on my screen. So when I swipe to one side, you see there's the swiping executed, and you directly see in the transmission what I'm doing on the device, or what interactions are on the device executed. So to run the test here, I create a new test suite. I start again with the quick start wizard. Let's say this, an iOS application. I say I want to connect, do this on my device. So I select the device here. I select the application which I have prepared for the device. Again, you need a special build for devices and a special build for simulators. Maybe I don't want to reinstall it. If it is already there, I would use this and finish. It creates the same start procedure, the same start sequence as before, only that the selected device here is now device. And let's run it to start the test on the device. And then during the instrumentation step, there is a problem now. It says, well, you cannot, without having developer team specified, executing any applications or tests on device. This is because also our agent is an application, and Apple is pretty restrictive with what it is allowed to be installed on devices and what on which device. So having said short, you need a developer account from Apple, which in the basic version is free, and need to tell QF-test about the information from this developer account. For this, you can open the settings, go to device testing options, and fill in here your code signing team ID. In case you don't know this by heart, you can look it up in the keychain. So I select the keychain here. You can search for the Apple developer certificate, which I have here, and copy the number from the organizational unit to my QF-test options, and let's rerun this. Now it's proceeding, it's looking better. And during this instrumentation and start step, Xcode in the background does all the things about getting a certificate, getting a provisioning profile, installing this provisioning profile on your device. If you do this the first time, you might have to go into the settings application and then the VPN section, interestingly enough, to accept this provisioning profile, but also there QF-test will help you with information in the manual. And as you see, now the agent was installed also on the device and the application was started. Luckily, it looks the same as on the simulator. So I can also execute the same test as I have been executing before on the simulator, and it's executed on the real device. You can take a look on the device. After some time on the device, there will be an overlay It's like a gray semi-transparent overlay saying automation running, but this automation this overlay in no way prohibits interaction with the device or test interaction. So you can run this as if there is no overlay. So what we've seen today was how iOS testing works with QF-test, what has to be installed on the system in order to run the test. We've seen the car config demo as a pretty interesting and pretty exhaustive application for rich interaction with an iOS application. We have seen a simpler demo which just does a hello world test, which can also run on older systems. We have seen how to start a new test with the quick start wizard. We have learned about the standard procedures for iOS tests, for example, rotating the device. And we have also learned about special variables in the QF-test group, which we can use to bring to test the different versions, to use parameters from the device during your test, for example, for different branches or tests. That's pretty much everything I wanted to present you today. If you're now eager to start testing and you have Mac next to you, let's get started. You can use your current license or to test this directly. And for this week, you have still the possibility to use any QF-test license to run iOS tests, but you can at any time also visit our web page and get an evaluation license to see whether iOS tests now is a good way to complete your test environment. Thank you very much for your interest. I will now stop the recording and then you can ask questions. Thank you very much.